It is my privilege to introduce an eminent academician, Dr. Sonali Agrawal ma'am, who has made remarkable contribution in the field of information technology. Currently, serving as an associate professor at Indian Institute of Technology, Allahabad, ma'am has dedicated her career to advancing knowledge and fostering innovation. With a PhD earned at IIT Allahabad, ma'am has been an integral part of Institute since 2009, imparting knowledge in operating system, software engineering, software project management. Her commitment to education extends to guiding various MTech and BTech projects, shaping the minds of future technologists. Ma'am's research interest spans a diverse range of cutting-edge topics, including stream analytics, big data, stream data mining, complex event processing system, support vector machines, and software engineering. Her contribution to academia are further exemplified by her roles in conferences where she has served as General Chair in ICONIP 2022, Publicity Chair for PAKDD 2021, and Organizing Chair for BDA 2021, among others. In addition to her academic endeavors, ma'am actively seeks collaboration and engagement. She is currently looking for highly motivated students to join her in exploring exciting realms of big data, stream processing, machine learning, and software engineering. Moreover, she is open position for junior research fellow and senior research fellow, inviting individuals to delve into the underlying theories and algorithm of machine learning and big data. In conclusion, ma'am, it's not just an educator and researcher, but a driving force in shaping the future of information technology students. Her extensive experience, unwavering commitment, and collaborative spirit makes her a beacon in the academic community. Please join me in welcoming the heartfelt welcome as she embarks with us on the present situation. Kindly, ma'am, please come.
So, very good morning to all. Before I start my discussion about the mentioned topic, first I would like to thanks all the organizers for giving me this excellent platform and this wonderful morning where I am really feeling very happy that I am getting a chance to interact with you all, and I'm here to share some of the research experiences in this related area. So I have chosen the topic which is not very technically covered today because of the limited time, but maybe it will give you a thought what are the recent challenges we are going to face, and what are the upcoming problems which are still available as a challenge to the researchers community. So the title you can see is Can We Trust AI and ML Models and Applications? So we know that we are using these AI ML models in every, you can say that, maybe you can say that it's like every minute we are using somehow these applications. It's so close to our day-to-day functioning. So that trust is very important. So this I am going to cover. So for that, we are having a recent development that is coined as a new term, that is explainable AI. So explainable AI is a kind of bridge which is going to fill the gap where the AI ML outcomes are creating trust and a kind of transparency among the end users. So this is the theme of this particular discussion. Excuse me. I think it's not working. Okay, so I need to, okay, so like this. Okay, so very briefly I am covering these particular topics. So we will be starting with the background part, then the introductory XAI, and then some basic information so that one can explore the topics, and then some of the use cases, and finally with the help of some concluding remarks, I will be happy to interact about the particular topic. Okay, so we all can see this is the reality nowadays. So we are using machine learning everywhere. So for example, like whenever we are traveling, we are using GPS navigation apps. Whenever we are searching through Google or maybe through some shopping websites, so we are getting recommendations based on our personal interest. And we are also very much enthusiastic and hopeful about getting very, you can say that advancement in technology, for example, like driverless car and many more. So this is the reality, like machine learning is everywhere. But another important concern is like machine learning is, these systems are ubiquitous in nature. So basically there are a lot of things which are hidden. And hidden means it's like a black box. They are very fast. All these learning paradigms are very fast. We are getting the results within a fraction of seconds. But the problem is like how they are working, maybe most of us are not known. Since we are belonging to a technical community or a background, so we have some idea like how the machine learning algorithms works. But those who are the simple end users, they feel like it's a miracle, like how within a particular minute of a second, how they are getting the output. So basically here there are the requirements which are very prominently triggered nowadays. That is the explainability part. So how machine learning is working, everybody is interested to get that explanation. So the question comes like explanation for what purpose? So explanations are important for very clear understanding. That is the one very simple requirement. The another thing is explanations are required so that the end users can feel more confident and they can have trust with the particular system which they are using. So here we can say that explanations are very important for our day-to-day purposes, especially when we are dependent upon these kind of technologies. So this is the fundamental, you can say that important explanation regarding the shortcomings of AI/ML models. So you can see here like AI/ML models are most of the time, they act like a black box model. And even if we are programmers nowadays, we are researchers nowadays, it is having very rich in terms of already available libraries. So even we don't need to understand each and every step within that library. We may simply give our input and we may get our output. So you can understand that it is behaving like a black box. But when the decision are going to affect the end users or stakeholders' life, they may have various questions. So the questions are like somebody is interested how they are getting this particular decision. Let us take an example. Suppose I am applying for a loan, and if my if the decision is like I am not I'm not having the loan approval, so maybe I'm having all the rights to get the explanation why my loan application got rejected. So there are various financial institutions, they are using some kind of automated scoring mechanism, and with the help of that they are giving the decision. So basically we need all kind of explanations, and these explanations are very important. So if we see the background part, like most of the AI applications are based on either supervised learning or unsupervised learning, maybe semi-supervised learning, and there are some recent developments which is reinforcement learning, and finally we are getting all those systems automated in terms of expert systems. So these are the systems where the same problem exists, and the problem is we are getting very quick decision, but these decisions are not well explained, and the systems are mostly working in a black box manner. So this is the background where this explainable AI exists, and where we are getting a lot of, you can say, attention from the research community to explore more and more about the explainable AI methods. So it is basically dealing with the explainable models. When we talk about the explainable models, means those models which are very much easy to understand, which are very much easy to learn, plan, and they are having good level of performance. And this good level of performance means we are expecting good level of accuracy, optimized solutions, precision, and finally the acceptance from the stakeholders with more trust and with better level of confidence. So this is basically the aim of the explainability which we are going to introduce with the AI ML models. So there is a common understanding now, like explanations are important. Then the next question comes, like what kind of explanations are actually going to be helpful? So sometimes we say, like whenever we present any results, so we may give visual explanations, or we can have more elaborative results so that no further steps are required for these things. Or we can say that like results should give all cause and effect kind of views, or results should have full, you can say that graphical representation or some kind of scoring and some kind of quantification, so that no further queries are required and it is well explained. So there can be various methods of explainability. So this is basically the point where the explainability is having lot of potential to work with and proceed for various kind of research problems. So this is another example, like suppose there is another use case, like we have seen like there are various algorithms and they are predicting about the healthcare concerns. So suppose the healthcare concern is nothing but the readmission risk. So readmission risk means suppose one patient is having some kind of medical history and whenever the patient got released from the hospital, maybe the first time or after the diagnosis of that particular disease, obviously the next question comes like how better he is going to recover, and if there is any chance to readmission, how we are going to calculate. So suppose if any patient is there and he is in the recovery phase, and suppose if I am being an AI ML expert, suppose I am giving the hint like maybe in next future, maybe in next 1 month or 2 months, or maybe in coming winter you are going to again face the same problem and you will be here. So he or she may ask like what are the reasons why I will be not going to fit and for forever, or what are the critical parameters which may be fatal to my health condition and how I can recover that. So at least I should have certain points so that I can explain like these are the parameters, maybe the vital parameters which are sensitive or critical and you need to manage it. So these kind of explanations are required. So suppose if the person is like if the decision maker is the expert, so manually he or she can explain. But if the decision makers are not the expert, but they are some kind of automated algorithms or some kind of platforms, so maybe that explanation needs more input from the developer side so that we can give appropriate explanation to the particular patient. So this is the difference you can see between black box AI and explainable AI. So black box AI means we are getting simple decision but not more explanation. When we talk about explainable AI, so we are getting decision, and after this decision we can also provide feedback to the AI ML model so that if we need better decision, so that can also be worked out. So basically when we deal with the black box model, most of the questions are not well answered. But when we are doing the explainable AI as an additional step, or maybe together with the AI ML step, then we will be getting all the understanding about the decisions which are taking place during that particular exercise. So basically it is going to provide us a clear and more transparent prediction about the task. So as far as the taxonomy is concerned, so we can have various categories of explainability. So for example, like if I want to clearly understand what is happening within that particular system or automated system, so I have to understand what are the inputs, and how these inputs are important. So maybe if there is a software and it is taking suppose 20-25 parameters, so we should understand like why these 20 parameters are important. Are they equally important? Maybe there are certain inputs they are more sensitive, more prominent, and others may be supportive. Similarly for the output. For output also we need to understand whatever output we are getting, which are the most sensitive information, where we can claim maximum accuracy or maximum precision, or there may be certain part of the output may not be very close in terms of accuracy or precision. So basically these are the two different aspects whenever we are dealing with the explainability we need to explore. So basically we need to explore the explainability in terms of input. We need to explore the explainability in terms of output. We have to also see like how much explainability we can provide. So suppose if I am giving you the result in terms of like fail or pass, so anyone can ask like if the candidate is pass, then what is the score? Or if the candidate is fail, then what is the score? So what should be the level of explainability? Should I give the proper score so that the candidate can be very well examined? Maybe if I am saying that, okay, the candidate is excellent, so you will ask like why you are keeping him in an excellent category, why not very good or medium or average or poor? So basically that skill set has to be mapped. So these are the important information, and finally we have to also see where we need to give the explanation. So for example, like if we can see like we are dealing with the interactive systems nowadays as a most of our application. So do we need explanation in each and every step? That may be very helpful. Or maybe at the end of the day we can feel like, okay, suppose you have used this chat GPT, which we are using very rigorously and very aggressively nowadays. At the end of the day, the chat GPT is giving us an email and showing an output like whatever you interacted with me or with the chat GPT, the information was only 80% accurate. So that is not going to help. But if suppose I gave some query and if I am getting the response along with the answer, like this response is up to only 80% of accuracy or up to only this much of domain or up to only this much of confidence level. So maybe it can give us more idea like how much we can rely upon and what else is required. So basically the stages of explainability is very important whenever we are relying upon these kind of models. So there is one important term which we believe whenever we are working with the automated systems or programming paradigm, that is interpretability. So here loosely we can say that interpretability and explainability is the same thing, but you can say that an explainable system should have better interpretability. So that is the very common connected word. So I am moving ahead with some of the other details. So the question comes like, suppose we are using some AI ML model and we want to make it more explainable. So what kind of techniques are important? So one technique we can say that the explainability should have graphical and visual formats. So you can keep more and more graphs to explain the aspects, or sometimes if possible we can have a textual or auditory or maybe verbal kind of explainability. So that is also very good. So whatever is going on, if we can get every step by step information in terms of text or audio, that is important. Or we can also expect that there should be a mixture of graphs, text, audios, so that whatever is going on, it has to be communicated to the end users or stakeholders for better understanding. So these are the various kind of formats where the explainability can be explored. I am giving you one example. So suppose it is a very simple task where we are using certain machine learning algorithm to get some job done. So now someone can ask, okay, give me where is the scope of explainability. So you can say like explainability is available at each and every stage, means it is it can be possible at each and every stage. So for example, like objectives. So definitely, whenever we come up with some research objectives, the first question comes, can you explain your objective? So first thing is like, whenever we are dealing with certain set of problem solving technique, so it's better to have explainability at the objective level. Then you can say that we should also define the scope. So sometimes what happen, we are working with the automated systems, but we are not getting the desired results. So we say that, simply say that, okay, this is not working good. So because maybe our requirements are beyond the scope of that particular system. So we should also know where is the scope, means how is the scope is defined. Then you can see the third important point. So some algorithm we are using, suppose we are using a simple regression algorithm. So we have to give explanation at each and every stage. So like what are the variables, for what purpose we have used it, what are the parameters, and what are the various other steps. So basically these explainability is required in all those phases. And finally you can say that this is a model which we are going to learn. So this model is having various kind of explainability scope, like you can scope the variables and parameters, you can scope, we can define the model functioning, we can define the role of the data which we are going to use there. So maybe the data is having certain set of importance, and we can also explain every step of the algorithm, like what we are calculating within that particular steps. And finally we can show the end results with the help of certain set of graphs. So basically you can see that explanations are required at any step or every step, and it is going to help us a lot to understand not only the results but also for shortcomings, and also for the improvement, and also to explain the end user so that he can have the better trust with these particular systems. So suppose we are trying to develop a system which is explainable AI based system. So we need to answer these 5 questions, like explain to whom, definitely depending upon the end users. So suppose if the end user is a non-technical community, so maybe they are only interested to experience their utility part about the particular package. So that kind of explainability. Suppose the end users are developers or researchers like us, so maybe we want more detailed information about the internal functioning of the system. So that is important, the roles are important. Then why to explain, the purpose may be different. Someone wants to get the explainability for better understanding. Suppose I am the researcher, I want to get the explainability so that I can see the shortcomings. I may target for its improvement, and maybe I am trying to get more accurate model or results. And then how to explain. So explainability is definitely, it should be as simple as possible. Then when to explain, maybe every step is required to be explained at the same time, or maybe we can have a summarized explanation later. And finally, like what are the various explainable technologies which we can follow. So this is the background behind the explainable AI, and you can see it is about the legal side. So there is a term which is the basically comes, it is known as right to get informed. So we all understand like right to information act is here, but right to get informed is the similar requirement. It is legally bound nowadays for all the working agencies. So suppose if we are somehow we are affected by any AI ML software or any service provider where these kind of automations are implemented, and where directly we are getting some results. So we have all the rights to get informed about each and every detail about that automated system. So suppose if I am getting some score, maybe my civil score that is related to our financial credibility, and we get this score to get some kind of loans. So if I am getting my civil score up to certain factor S, so I have all the rights to get the idea like how my parameter is this much. If I want to improve, then what are the weak points where I can work and we can improve. So this is the very important background. So this is the regulation now. Whatever automated softwares we are developing, whatever results we are generating, if somebody is challenging those results, so that person is having all the right to get informed how these automated systems are generating those results. So for that, we should be ready with these kind of explanations, whatever I have shared. So that is all about the background part. Now quickly, I will give you the taxonomy, that is in terms of level, types and methods. So I think now it is, I have given enough hint. So it is very clear that whenever we are dealing with the AI ML model, we can introduce explainability at the very early stage, which we call pre-modeling explainability. So the term is new, but the exercise is not very, you can say that new. Pre-model explainability means understand the problem, understand the objective, explain well the objective, get the data and explain all the data elements, why they are important. Then also maybe understand the nature of the data, like whether the data is dense or sparse and what is the minimum value, maximum value, what is the skewness, and if the data is having any kind of outlier. So basically understanding all about the data before it's a training part. So that is actually the pre-modeling explainability. So once we understand, so we can easily see like this is the critical parameter and this is going to affect our decision making, and we can understand like what kind of data we are having. Maybe the data is having sparse characteristics, or maybe the data is skewed in nature, or the data is dense, or maybe certain parameters are working together. So for example, if I know like there is a person with high income is having good credibility in terms of getting the loan. So why to take two fields, like two columns? Maybe I can remove one column because they are progressing in the same way. So that kind of understanding we can get. If this kind of understanding we are having, so we may reduce certain columns which are like having the similar fashion, and we can improve our computational capabilities. We can minimize the load. So basically these are the pre-modeling explainability steps which we can take. The last one you see first, that is the post-modeling explainability. So post-modeling explainability means we performed machine learning task or some kind of AI algorithms, and finally we got some results, and that result needs to be explained. So suppose I'm getting a score maybe like suppose polarity. Polarity means suppose I have written an article, and that article is having either positive polarity or negative polarity or maybe neutral polarity towards certain context. So suppose I am getting that article is having negative polarity. So I should able to understand which are the sentences responsible for my negative score. Maybe certain keywords, maybe I have used some negative keywords, or maybe I have used some controversial words, whatever. So basically that is known as post-modeling explainability. Means after getting the results, let us explore how this result is coming and what are the parameters for responsible for those particular score or result. So that is the another one. So most critical one is the middle one, which I have mentioned here, is the interpretable mode of explainability. So interpretable mode means step by step, whatever you are doing, you need to explain all the steps. And we all know the reality. Maybe if you are undergraduate or postgraduate student, or maybe you are an early career researcher, along with your job, you get limited time to explore these kind of research problems. That is the reality. So there is no time to develop any model from the scratch. And we are blessed enough where we are already having inbuilt libraries. So we can do any problem solving with the help of few steps, with the help of these inbuilt libraries. But do you go through all these steps? Do you have the explanation inside that inbuilt library, how it is written, how it is programmed? No. So since we are very much working in a black box environment, that is the most critical thing. So suppose you are using some kind of machine learning models like decision tree or ANN or KNN or maybe support vector machine. So you need to write only one line of code in your Python library. But where is the explainability? Can you explain which parameter is responsible for your outcomes? Maybe we are not aware. So basically we can say that interpretable mode of explainability is really critical, where we have to open these black box model, and for every mathematical step which belong to that particular algorithm, write down each and every step, what is happening, why it is happening, what is the input, what are the output, and how it is going to contribute for your end result. So that is a core part of the explainability, which is the intermediate level of explainability and most challenging part also nowadays, because we need to understand its importance. Most of the time we can do our job without considering this important phase, and maybe we can compromise some set of reliability or trust with the models. So this is all about the details. Now the question comes like what kind of methods we can perform. So as I already given you the idea, like we can have explainability with the help of input data. We can have the explainability with the help of output which we are getting. Then we can have the explainability in terms of scope. Scope is, for example, like local explainability, where every term has to be explained, or maybe global explainability, where we are not going to give the explanation in the step-by-step manner, but maybe we can conclude. Or finally, we can have the explainability again in one very important aspect that is very important for the research purpose, like do we need to develop model agnostic approaches or model specific approaches? Model agnostic approaches means there should be a common method of explainability. For example, plotting the graph is a common method. Whatever you are using, if you are getting some data as an end result, let us plot the graph and show. So this is the model agnostic approach. Model specific approaches are like if we are using decision tree, so maybe we are having different kind of explainability possibility. If we are using deep learning, so maybe we have, according to that deep learning architecture, we can explain it in a different way. So that is basically the model, you can say that is specific approach of explainability. So there are few important domains where we consider this explainability in terms of existence. So explainability is important when we are using the AI techniques. It is going to help us for better clear understanding. Explainability is important in terms of machine learning. Machine learning means we can take the help of dependency plots, feature importance, or some kind of surrogate models where we can get better explainability. Machine learning, specifically in the case of computer vision and deep learning, we can have some kind of heat maps or saliency graphs, and it can help us to understand the explainability part. Similarly, we can have the explainability so that we can summarize some kind of strategies, and we can also use the explainability aspect to plan something, or it is useful for various kind of search optimization. It is also useful for various kind of solving of the game theory problems. Similarly with the robotics environment, similarly with the natural language processing, and similarly with developing the user interfaces. So basically these are the domains, and in all these domains the explainability is somehow now it is a very important step which has to be incorporated, and lot of active research are going there to incorporate the explainability along with these well-established practices. So finally, I can give you some ideas like how we can summarize the whole domain. So summarizing the whole domain is having certain set of important metrics. So suppose if I am going to evaluate like how much explainability we have achieved for any kind of model, or maybe inbuilt explainabilities are definitely there, like we are giving some results. So if the score is high, so we understand that, okay, score high means the performance indicator is indicating maybe good success or something. But still there are some other parameters that has to be addressed. So we should somehow able to understand the transparency. So transparency is very important whenever we are working with these type of problems. Then the domain sense. Domain sense you can understand in this way. For example, like suppose you are using, for example, like Amazon shopping website, And if it is recommending certain product, like those who buy this book, they have also explored these books. So here the accuracy is not very important. Maybe somehow you can like this recommendation, or maybe you can going to discard this recommendation. So it is not very important how accurately they are recommending. But suppose if I am using these AI models for aviation control system, where the autopilot mode which is programmed and as per certain parameters. So here the explainability, or you can say that the results are very important, they are sensitive. So basically, according to the domain, we need to develop our level of explainability. Then consistency is also very important. So whenever, like if you are looking for certain automated systems, so we assume that this automated system should come up with the similar results, whatever inputs are there or whatever circumstances are there. So that is actually the consistency. Parsimony is also important. So parsimony says that we should be very accurate in terms of the individual contribution of every parameter, whatever is available to that particular system. Similarly, generalizability is very important. So generalizability says that if we have developed a explainability understanding, so it should be applicable for all those variations of that particular model. So lastly, if we are achieving all those, so definitely we are achieving good level of trust, performance and credibility. So these are the explainability parameters which are important role players. Then there can be synonyms of explainability depending upon the situation. So someone can say that explainability is nothing but it is comprehensibility. So comprehensibility means how detailed or how much effort which we have incorporated to get that explanation in terms of human understanding. Okay, sometimes we can say that explainability is nothing but it is the succinctness. So here we can say that we are comfortably understanding the paradigm in terms of its concise and compactness. Sometimes it is nothing but to get good level of indication in terms of which actions. Sometimes we can say that explainability is nothing but it is the indication about the you can say that flexibility in terms of its reusability part, and obviously these explainability will going to help us in terms of the accuracy part as also in terms of the completeness part. So these are some of the common, you can say that related keywords or the synonyms where the explainability is going to support us or come up with some level of sense. So finally, I am going to provide one very important observation. So you see this particular graph, or you can understand one example, like we have two types of machine learning model, means there are categories of machine learning model. Let us see the most simple machine learning model, which is decision tree, right? So decision trees are very simple. But the decision trees are having limited applicability, but they are very simple and they are well explained. So we can say that there are these are the conflicting things. So those machine learning models which are simple, they are simple in terms of problem solving also, and they are having very good level of explainability. But there are complex problems which we are dealing nowadays. For example, like computer vision problems, or maybe the real-time computational problems, or maybe we are having very high load in terms of computation, for example, like image processing or some large volume of data processing. So here these decision tree will not work. So we will somehow go towards the recent developments, for example, like a deep learning model. So deep learning models, they are working very accurately, but they are not having that level of explainability. So once you are using a deep learning library, you will not having all the clue like how it worked and what results you have received. But if you are working with the decision tree, maybe you can simply guess, okay, this is a very simple formula like less than, greater than, and it is like having some decision function and it is dividing like this, and finally I am getting the result. So this is the very important part, like simple machine learning models are unfortunately having low level of explainability, and they are not capable enough to solve challenging problems. The recent machine learning models are capable enough to handle very challenging tasks. They are highly effective in terms of keeping all the computational load, but they are basically not that level of explainable. So this is what we need to work nowadays. So if we are promoting this explainability, so we have to identify the trade-off. So either identify the trade-off in terms of your choice, so that whatever model you are using, it should capable enough to solve the computational challenges which we are facing nowadays, and it should also capable enough to provide the explainability which is highly desired when we are keeping the stakeholders' interest in terms of trust and confidentiality at our maximum priority. So this is basically the graph which is showing like the accurate models which we are using in terms of simple models. So the models may be simple, the models may be accurate, but they are not enough to solve the complex problems. And if we are going for the recent models, they are very strong, they are very effective, but they are having the poor explainability. So that is something very important. So finally, we need to identify certain kind of trade-offs between fairness, performance, transparency, user privacy, and ultimately we should also achieve the explainability which is required. So these are certain challenges. So the challenges are like, if we are working for the explainability, so we should keep this legal foundation to our minds, like the customer or the end users or the stakeholders, they have all rights to get informed. So how we are going to provide them every information. And then we have to also show maybe these information, providing the information is having some kind of privacy restrictions also. So suppose somebody is going to say like, I need explanation of each and every step, but there are certain strategies which we may not be able to disclose to the stakeholders or end users. So how to keep balance on all those, that is something which is important. Other than this, definitely if you what to target, whether to target the performance or whether to target the explainability, that is again an important concern. If we are targeting the performance, so maybe explainability may not be very much addressed, but somehow we need to get all the you can say that a kind of trade-off situation. So this is the same graph whatever I tried to explain. Like you see that the simple models are not that powerful, but they are better explainable. And the recent models are very powerful, but they are having the poor explainability. So there is a gap, and that gap has to be fulfilled. So definitely we want not to compromise with any of these expectations. So we need a high level of models. High level means a very accurate model along with good level of explainability also. So this is the research gap which we need to fill nowadays, and this is something which is an active area of research, and a lot of possibilities are there to work upon. So I think this may be the concluding slide with the message of the future scope. So we can say that now we are flooded with the AI ML models, and we are using AI ML everywhere, but the word AI is not enough. Can we include one more keyword with this, that is the responsible AI? So responsible AI means we are making sure that whatever decisions we are taking through some automated AI ML models, these decisions are full of responsibility. When we say responsibility, so they should be accurate, it should be transparent, it should be fair, it should be ethical, it should be full of accountability, or finally, you can say that it should be in a safe fashion. So AI term is standalone, is not fulfilling the purpose of the need, means the real world requirement nowadays. Let us rename this as a responsible AI. So once we say responsible AI, means we have all the explanations available so that we can build better trust, better confidence with the scenario which we are living nowadays, and it is definitely the world of AI and ML. So with this, I am concluding my very brief explanation or maybe my research experience in this particular field. So even I am still learning and there are a lot of things to explore. So I would like to draw your attention to this particular topic so you can explore and you can find it interesting. Maybe if you are not going in deep, then also it is very interesting. And definitely I will be happy if I can receive some kind of feedbacks or maybe some of your remarks to enrich my knowledge in this particular domain. So I'm open for the questions, please.
Excuse me, ma'am, I have a simple question. I belong to actually physics domain, but still I'm working on astronomy also.
Okay.
So we are working with also Computational in IIT Kanpur.
Okay.
So initially we are working on antenna. Okay, it's not having any array system or bulky system. Okay, so what's the problem? Like suppose we are getting the radio signals into it and then put it to the computational system. But the thing is how this XAI will help us to read out the entire data and how it signify the signatures of or movement of the celestial bodies, their positions.
Okay. So, well, I am not aware about the particular domain which you are working, but if suppose as a data scientist or a data analyst, I need to propose like where we can introduce XAI in your domain, so definitely the very first step you can perform like whatever data you are having, so you can go with the, very simple thing is go with the exploratory data analysis. So exploratory data analysis is nothing but first follow all the statistical measures computation. So you can calculate that you can calculate the centrality, you can calculate the sparseness, you can calculate the skewness, you can see where the outliers are exist or not. Then the second thing is you can go with the feature engineering. So feature engineering means very simply we can see which feature or which attribute is important. So every feature is having certain importance, so we can go for the feature engineering part. Then we can also go for dimensionality reduction part. So as an example, I says that if there are two parameters x and y, and these two parameters are having similar fashion, like if x is increasing, then y is also increasing. So why we are keeping these two parameters? Because they are having the same pattern. So let us remove one, maybe it will help us to reduce the computational load. So that can be a kind of dimensionality reduction. So there are other various methods of dimensionality reduction. So I think with the help of this feature engineering, especially this dimensionality reduction part, or maybe with the help of exploratory data analysis or confirmatory data analysis, you can understand the importance of your individual data and you can target only few elements rather than keeping the all raw data for your further analysis. So this we usually do as a starting step when we apply any machine learning algorithm.
Sir. I just want to discuss, first of all, very thank you for sharing your vast knowledge. And this is the second time I am listening to you. Some days back, we had a detailed discussion in NEP and relevance of NPTEL courses delivered online.
But I was not expert for that NEP part because, you know, NEP is something which needs a very philosophical understanding and all our senior professors, they are more suitable person to address those,
My question is, the discussion is, in 2014 and 15, I have started working on the term EHR, Electronic Health Records.
Okay.
I don't know, fortunately or unfortunately, I have stopped working prior to taking some copyrights from Government of India. And 2019 onwards, it became a buzzword after COVID-19.
Yes,
Working on this. As long as this explanatory AI implementation part is concerned, actually my algorithm was related to the security part of a patient's records. The age, the...
Security means that privacy.
Yes.
Okay.
Encryption and decryption.
Yeah.
As long as this explanatory AI is concerned, my question is, what kind of limitation we would have? Suppose we need to do a lot of interaction, we need to train our model, we need to change the parameters very frequently. So as long as complexity is concerned, you know, when we go for the performance part, performance and accuracy, complexity will increase. So how, is there any limitation on in black box implementation or related to parameters?
See,
You can go for any extent. I mean,
so that's what I was trying to say. Like if you are using a simple decision tree, maybe you are getting very well explainability, but maybe not the performance. If you are using a deep learning architectures, you are getting lot of performance related satisfaction, but may not be the explainability part. So actually that is the question, like where to have the trade-off. Trade-off means we should not, we should consider the complex problems, we should not compromise the accuracy part, and we should also have the good level of accuracy, explainability. And the problem is these recent advancements are so rich in terms of the internal details, and that is actually hidden from us. We are using it only as a architecture part or available framework part. So this is really a challenging thing what you are asking, like how we will decide. Like suppose if I want to unbox a deep learning model, so it's simply a very challenging task, like how to unbox it. Even if you go the mathematical explanations behind the support vector machine, because I did my PhD on that, so still now I am not very confident. Like every time I come up with some new question which needs more study and more explanation. So that was the very simple technique or very simple algorithm. And even here the deep learning models are completely closed. So we don't know what is inside, and we have, if there is a PhD problem, then definitely one can explore so many things. But like us, we are having limited time to research. If I want to unbox all those things, so it will take a lot of time to understand. And the research is, actually people are not doing on that way. People are very active to just utilize those libraries, but nobody is going inside those libraries and providing the explainability part. So that's what it is coming as a very big question. Like if end users are affecting with that outcomes, so we should be responsible and we should be providing all the explainability why it is happening. So there is a, definitely we can come up with some trade-off, and that is the actually area of research, how to explore that the trade-off point.
actually, what exactly happens when we go for some research papers to answer our queries? What I realized, what my observation is, people have targeted only one parameters in their particular context. Some researchers have targeted only the performance part. They have not talked about the output accuracy or maybe the response time, maybe set of input parameters. Some people have talked about only the complexity. They never talk about the trust related to that.
Yes.
So many times we feel that our question or query remains unanswered.
Yeah, so you can understand it like this. Like I am teaching the software engineering subjects also. So when we, suppose if we are giving an order to develop a software to some vendor, so we will say like, okay, we want a accurate software, right? We want a, for example, like we will say like we want a flexible software so that we can program it as per our requirement. But on the other hand, you will say, okay, we want a software which should be secure, maximum secure. So actually you have two conflicting requirements. One, you are asking for security. Second, you are asking for flexibility. So how security and flexibility will come together? So suppose I want flexibility of editing the dates, and I can go back to the back date, maybe corrections and all. So this is flexibility, but this is not security. So this is the thing, like flexibility means, suppose I want like, okay, I am the maybe the higher level of authority. Let me give a chance to edit all my juniors' account and their log files. So that can be flexibility for me, but that is not the security thing. So this is the problem. Like every time, whenever we expect anything, we have a conflicting expectations. So how to these two conflicting expectations will come together. So this is the problem, and
where my trade-off is going to be selected, that is probably the value of the game. Depends algorithm.
Yeah, it's even it depends the domain requirement also. Yes, domain. So there are certain domains where we cannot compromise the security part, and if we are not going to compromise with the security part, maybe flexibility will be 0. Okay, and there maybe we can compromise with the security part, so we can give good level of flexibility. So it depending upon the domain requirement. Yes. So thanks for this interaction, and any other questions, please, sir? See, basically, most of the this deep learning models for highly computational problems where the computational load is high. So suppose if you are dealing with